Great. So this is question 3 from Summer 2011, core 3. Part A. Given that 7 sine 2 alpha equals 3 sine alpha, where alpha is between 0 and 90, find the exact value of cos alpha. Okay? Well, we need to get these two things in terms of the same thing, don't we? So we're starting with 2 alpha over here and alpha over here. Remember this list of identities that we've learned, that we can now come out with at any time because we've made sure we know them. And sine 2a was one of those identities. It said that sine 2a was 2 sine a cos a. So 2 sine alpha cos alpha is 3 sine alpha. So we've got that. Now we're used to equations all being on the same side, so let's take everything over to the left hand side and say we've got 14 sine alpha cos alpha minus 3 sine alpha is 0. And what we're going to do next with this? Take sine alpha out. That's the common factor, isn't it? Now we've got sine alpha as a factor of both. So we'll take sine alpha out as a common factor. 14 cos alpha minus 3 is 0. We've now got two things multiplied together that give an answer of 0. So that being sine alpha is 0 or 14 cos alpha minus 3 is 0. And this one, there's an interesting little thing in this question, a little trap that has been set for you. Sine alpha equals 0. Well, that's great, isn't it? Sine alpha can equal 0 at lots of points. At 0, at 180, at 360. But look, we were told alpha was greater than 0 and less than 90. So in fact, in that range, there are no values of alpha that make sine alpha 0. It's only just because 0 would have worked, but 0 isn't allowed. So there are no solutions in 0 to 90. Not sure that in was the right word to use there. Sine alpha can't be equal to 0 in that domain. So we're left with this one, 14 cos alpha minus 3 is 0, which means that cos alpha is 3/14. There's some great calculator work going on down here, and we get 77.6, is that? So alpha is 77.6 degrees to 3 significant figures. Oh, but hang on. I'm sorry, I shouldn't have done that, should I? Yeah. The question says, find the exact value of cos alpha. 3/14 was it. We didn't need to put it into the calculator at all. There it is. Okay. Part B. Given that 3 cos 2 beta plus 19 cos beta plus 13 is 0. Oh, hang on. Where is it? So this is our equation now. 3 cos 2 beta plus 19 cos beta plus 13, 0. Oh, but look at this. This is a bit odd. Where beta is between 90 and 180. And this one wants us to find the exact value of sec beta. Right. So what do we do with this? Well, again, we've got 2 beta and beta appearing, so we want to sort that out somehow. Cos 2 beta. Now we can either do this in 2 stages, or we can go straight there with this. Remember, cos 2 beta are identities that the cos A plus or minus 1 thing tells us that cos 2 beta is cos squared beta minus sine squared beta. But then we remember that the Pythagorean identity from core 2 tells us that we want everything in terms of cos here. Sine squared is 1 minus cos squared. So that is 2 cos squared beta minus 1. So that's what we're going to substitute in. So instead of cos 2 beta, we're going to do 3 lots of 2 cos squared beta minus 1. plus 19 cos beta plus 13 is 0. This is looking very much like a quadratic equation, which I hope we're going to be able to factorise. Six cos squared beta plus 19 cos beta plus 10 is 0. Now it depends how confident you feel with this stuff. You may want to write this as being 6x squared plus 19x plus 10. If you have a Casio FX991EF plus, then you can put it into the equation solver and get it to tell you what it factorises as. Or you can try and factorise that however you remembered it from last year. I like this thing where you multiply the first and last things together to get 60x squared. You then say what multiplies to give 60 and adds to give 19. Well, 60 is 160, 2 times 30, oh, it's 4 times 15, isn't it? That would work. 4x and 15x. You then split it up into 6x squared plus 4x plus 15x plus 10, and then factorise the first two terms, 2x times 3x plus 2, and factorise the second two terms, 5 brackets 3x plus 2, giving us 2x plus 5 and 3x plus 2 as our factors. Okay, giving us x is minus 5 over 2 and x is minus 2/3. I do like this whole factorising method. It's neat, isn't it? And then we go there. So we now, this was, of course, it wasn't about x, it was about cos beta. So cos beta, go back to where we started, is minus 5 over 2, and cos beta is minus 2 over 3. But of course, cos is just, if you think of the graph, it's just going between plus and minus 1 all the time, isn't it? And oscillating like that. So cos of beta can never be minus 2.5. So that one has no solutions. We're not going to bother with that one anymore. We're left with cos beta equals minus 2 over 3. We just want to check, does that have any solutions? Well, if you think about, remember what cos does. Cos is going like that, isn't it? And there's 0, there's 90, there's 180. And so between 90 and 180, cos would be negative. And it would be between minus 1 and 0, and minus 2/3 is there. So that does have a solution in the range 90 to 180. So that one is fine, we're really happy about that.